So I want to be able to show this as one log, okay, but I can't combine these. It says minus, but I've got this extra times 2 here. So if this was just log and log, I can kind of combine it by minus or division. But before I can do that, I think I need to get rid of that 2. So I'm going to end up with log base 5 of 3x minus log base 5 of 4x 4. Now be careful, don't just apply the exponent onto the variable parts. It has to apply to that whole argument. Okay, so again, this is an issue that came up earlier with applying exponents to bases. Same thing applies when you apply the exponent to the argument. So now that I have log base 5, log base 5, I can combine them since the bases are the same. I'm just going to keep that same base, and the argument parts, that's going to be a positive log, so that's in the numerator. That's a negative log, so that goes in the denominator. And we can simplify the x's. We probably should. Okay, so there is that expression combined into one log. This next problem here, it can be done in a couple different ways. So I'm going to show you one way to do it, and then I'll show you the other way. Okay, and it really doesn't matter which way, but these questions are kind of intended for you to do this in the log form, but these problems can be done in the exponential form. So in the log form, it looks like this. Log ax equals 4. So what we want to do is isolate a log ax, so then we can replace it with a numerical value of 4. Well, to do that, I'm going to split up my log using log rules. So I'm going to split the x squared and y cubed using plus. Okay, so I'm going to log x squared plus log y cubed. Okay, but I want to also take that and bring that to the front. Okay, so that becomes 2. Oh, that's not a very nice looking 2. Okay, so I'm going to bring that squared out front. Same with that cube. Okay, that cube comes to the front. Okay, so then what I can then do is I have that log base a of x equals 4. I'm going to replace that yellow with a 4. Log base a of y equals 3. So there's my log base a of y. I'm going to replace that with 3. So then my answer works out to be, I'm going to get a numerical solution. 2 times 4 plus 3 times 3. That's equal to 17. Okay, so the answer for this is 17. Now we can get this exact same solution this way. And I prefer you doing it with logs, but it can be anything with logs can be done with exponents. So I'm going to redefine this. Okay, so the log I'm going to define as an exponent, and this other log I'm going to define as an exponent as well. Okay, so that's going to be the blue one. And what I can do is I can replace those x's and y's with base a's in the log form. So it becomes log, okay, x squared y cubed, like that. And I'm going to replace the x squared with a to the power of 4, and the a cubed with, the y with a cubed. So then this works out to be power 8, power 9, add them together, power 17. I'm going to use one of my identities and get that equal to 17. Okay, so we could do this as a log problem, or we could do it as an exponential problem. Either way you get the same answer. Okay, I'm going to do the rest of these as a log problem though. So I'm going to split these up using my log properties. Base a, the power 2 comes to the front. This, I'm going to split up all my factors with plus. So there's going to be a times here, so I'm going to plus x. There's a times here, so I'm going to do another plus. And then bring that power 4 to the front. Okay, this is an identity. Log base A of A is 1. We really should make sure that we know that. And anytime you have a base, common base with a log and inside the argument, that should be worked out as a number. Log base A of x, well, we know that that's equal to 4. So we're going to go plus 4. And that's going to be 4 times log base A of y. We already worked that out as that's equal to 3. So times 3. So 2 plus 4 is 6 times plus 12 is, I'm getting 18. Okay, so same thing here. This one here you have to be extra careful. That 1/2 is not affecting anything. You could put it in as a power, but let's not. I'm going to split up all the logs with our rules, knowing that numerator has positive exponents or positive logs, denominator is negative exponents or negative logs. So I get log base A of A plus, because that's a times, x to the power 5, 5 comes to the front, minus, because now the y is a divide, log base A of y, and again the power comes to the front. Okay, I'm going to work out these numerical values. That's equal to 4. This one is equal to 3. And I'm going to substitute in my 4 and 3 into this expression now. So I get 1/2 log base A of A is 1. 5 times 4, log base A of 4, minus 2 times 3. Simplifying that all out, I get 20 minus 6 is 14, plus 1 is 15. I get 15 divided by 2 is my final log answer.